In this session, we'll look at databases, the entities that store the whopping 402.74 million terabytes of data developed by the web each day. So here is the real stats on what I'm talking about by Statistica, and it's actually really astonishing. So let's move on to talk about the two different types of databases. The first one being SQL databases, where you have tables and there's relations between the tables. It's also called relational model of storing data. And the second one is what we'll be experimenting on throughout these sessions. It is the NoSQL databases, where things, or we can say documents, are actually stored all together and are interlinked with each other. So what are the terms that are very common with SQL and NoSQL? For SQL, you are usually having a database, and within that database, you have a lot of tables that are stored. And within these tables, you have the data that is stored in rows, and these rows are generally called tuples. And so I'll write down over here tuples, and within those rows, if you see each, maybe if you have those headers, each of them maybe as a name or phone number or something like that, then they're actually called as fields. Whereas in the NoSQL databases, database is actually called database itself, and within the database, the tables, if you see, are actually called collections, and within each collections you have documents. So each of the rows of data are called documents. So I think that's enough of the key terms, and now let's move on to see how a SQL data usually looks like. So here I have a post table. Within that, you can see all the fields and you can see all the rows of data that is there. Here, one thing that you can notice, as it's a post table, usually in a social networking website or a social media platform, at times you might sign up but not post anything, or you sign up and post but there's no likes and comments available. Then things are going to be stored as null. But this null values can actually give in some errors when we have to maybe filter things or any complex functionality that we want to perform, and it does take up a lot of null, the memory space, because null values are being stored over there. So one more dynamic way of storing the data is through the NoSQL databases. That is, the data is usually stored in the form of JSON objects. So here you can see I have post collection, that is a table name again, and within that, if you see, all my data is going to be stored in arrays, and it's an array of JSON objects. So this is JSON, and here it's all stored as JSON objects. And how is that dynamic nature coming? If you see this person, user one, that is John Doe, he is posting something and there are likes. Some people are liking his comment and commenting as well. And suppose if you have within these comments, maybe some users are even liking the comments. So if you want to add something like that, then you can easily add the field comments or likes beneath the content. And here, if you see, for another author, Sam, you have the post, but there is no likes or there are no comments as such. So you can just omit it. So that way you're actually having a dynamic view, and whenever the data appears, that time you can add it in. If it's not there, then you can leave it empty. So you have that flexibility. So usually when you have social media platforms, a lot of data is being generated, and every time it can be fluctuating. Sometimes it might have comments, sometimes it might not have, sometimes there is no content, it's just the post heading. So whatever it is, it has to store everything. And to have a dynamic way of storing stuff, we are having documents. Okay, so these are this is one document starting from one parenthesis to the other, and this is the next one, and it's all in the format of JSON object. This is something that's usually asked: how is the NoSQL data stored in interviews? So that's basically the JSON object is the answer. Okay, so let's move on, and here's a summary. So here SQL databases, it's a type. So an example to that is MySQL, and for NoSQL, the example is MongoDB. That's what we will be downloading, and we will be using in our web app, our backend web apps. So over here, SQL is actually something that was developed very earlier on as compared to the NoSQL databases. So as social media itself is fairly new, the same way MongoDB and all those databases that store such data are also quite new. And here you can see in MySQL you have a table structure, whereas in MongoDB you have a document structure, as we discussed previously. And your SQL requires a schema. Schema is nothing but a collection of the fields. So you have to make it fixed in the beginning, and making some changes to it is actually a bit like painstaking. But in NoSQL, it's very flexible to change, as we discussed. Some of the posts can have comments or not have comments. It's all up to the user who's posting. And moving on now, how to integrate MongoDB to our projects. So the first initial steps is, the first thing is to install MongoDB. Now, if you're a Windows user, I have a video on how to download MongoDB and the Mongo shell that we'll be working on now. I have a separate video to that, and that's linked in the description, and you can go and watch and download it in your own pace. If you're a Mac user, then there's also another link to another set of video where you can download MongoDB for Mac as well. So here, first thing, you have to install that. You need to have it in your local environment. Then, as usual, we have to initialize npm as we are doing it previously. So npm initializing will create your package.json, and you'll install the dependencies as well. That is npm i express, npm i mongodb, and npm i mongoose. So now, what is this mongoose that we are installing? So this is actually a library within npm that is almost like, it's like a cherry on top, and it actually makes the life more easier in writing the MongoDB or accessing, or connecting our application with the MongoDB. So it makes our code more simpler to write. So that's why we're using this framework Mongoose on top of MongoDB to write the or connect to our databases. Okay, so after we do all this, I'll show you in live coding how is my file structure, my folder structure. But for now, what we are going to focus on our live coding session is how we can do these operations within databases as well. How we can create some, what I can say, we can create a table, how we can add in, create a collection, how we can add in documents. And once you add in documents, how you can read from it, and as well as update and delete those documents that you create. So we'll see all that in our live coding session. So let's jump right into that, and let's go to VS Code. So here in my project folder, I have my package.json. I have initialized npm, so that's why we have package.json, and here I have all the dependencies installed as well. So you have Express, so that resulted in the node modules, and other two we are going to use it now in our database.js file. So firstly, to use our database, we have to require it. So we are going to use Mongoose directly. And how can you connect, or how will you connect to your MongoDB that you install? The MongoDB that you install is actually hosted in the server 27017, and over there you'll have to connect to it first, and then you can write any name of your database. Okay, you can give any name. So this will create a particular new database and connect to the existing server at the port number 27017 as well. Now, the next thing you have to do is to create a schema to say what are the fields that's going to be there, what will be the data types of each of those fields. So for that, this will be the syntax over here, mongoose.schema. You can give the schema name. So this is, the whole example is about a fruit database where we're going to store some fruits. We're keeping the example as simple as possible because it might be the first time you're getting to know about all these different syntax. And moving on, here you can see, once I create my schema, I'm going to create my collection. That means a table. And I gave it a name, and I'm saying that this is the local name I'm giving, and this is the actual name, right? The model is nothing but collection, and that will follow the table. In that table will follow the fruit schema. That means it will have the name, rating, and review of these data types. So this is how we initialize everything. Now, if you want to create or put entries into your database, just one entry, then this is the code for that. First thing, you'll create a new instance of the table. You're creating a new instance called fruit itself, and you're giving the values for the name, rating, and review. And finally, you're saving it to your entire collection. So this is when we are just writing one entry at a time. So let's run this. I'll run this using Node, so that it doesn't like render all the time and you don't have a lot of fruits popping up in the database. First thing I'm going to do, node database.js. Okay, I think it's executed. Now, how will we go and check whether things are actually happening? So the one way to do that is to go to your Mongo shell that we have already downloaded. Hopefully you have as well. So to go to Mongo shell, you can just write terminal, and within that terminal you can write mongosh, and you can enter the MongoDB shell. And within this, you can write show DBs to check whether the database was really created or not. So here you can see somewhere here, you have fruits DB that we have created. You have like some data also. That's why it's showing 8 over here. So now let's look at the collections within the fruits DB. For that, first you have to enter the fruits DB. So you are using fruits DB, use fruits DB command, and now we have switched to that DB. Now here within that you can show the collections. Here you can see we have the fruits collection, and now to check whether the apple was actually added in, what we can do, we can use this command fruits db dot, and then we are going to write the collection name, that is fruits. Within fruits, find all the documents. That's what this entire command is saying. So this is particularly a Mongo shell command. So if you want to do this in your web app, it's going to be completely different. We'll be tackling that sooner now. So here you can see, once I click on enter, I can see an array, and within that we have one document created where our data has been inserted. So we have created our first entry in MongoDB. So now coming back to this code. So once I created one time, I'm going to comment it out. I don't want it to be created multiple times. And suppose you don't have just one fruit and you have multiple things that you want to enter into your database. In that case, you can create an array of all those things. So here I have a fruits array. Within that, I have each of those documents, right, with the fields and the values as well. And now I can use the function insert many to insert it. So I can use here, if you see, fruit is nothing but the collection name, the model, right? And insert many, and I'm inserting this whole array. So once you insert that, we are using the dot then function to say that, or give an output that it's been inserted successfully. And if suppose there's an error, that's also going to be printed out so that we can debug the code. So let's see if this actually works. The insert many, you don't need to have save over here. Insert many will directly insert it. Okay, so let's again come out and run this again. Okay, so fruits are inserted successfully. So this message is being console logged. That means it was done successfully. So let's go to the shell. Let's find it again and see over here, kiwi, orange, and banana. The 3 new fruits documents are added, right? Okay, so now we have seen how you can create multiple entries as well as a single entry and save it. Now moving on, how can we find or read through all that in the database and display it? So that's the next thing that we're going to see, that is displaying all the documents. So here if you see, for displaying all the documents, I'm creating an all doc function. It is going to be an asynchronous function. And if you see in JavaScript, when we use async, we always have await within the code. So here within this async function, I have my try block and the catch block. The try block will always contain what's going to happen. The catch will always catch the error. So what's going to happen? We are going to send or find the data from the database. So to find it, we will use this command fruit.find. Okay, find function. So fruit is a collection name. So inside that, find everything and display it to me in the result over here. Okay, in the variable, just put it all there. Now here you can see we're using await. The reason being database fetching and things can take time. So we are saying the code that once you have fetched the data, once you found it and it's being it came into the web application and you have stored it in results. Once that has happened, then only you console log. Okay, so once this await will happen, after that only you console log will take place. So async function again is this whole function is async, means suppose in case this function takes too long to respond also, all other functions within our page will get executed. It wouldn't just wait for this and nothing else is getting executed. That wouldn't be the case. Okay, so let's see if the entire async function is, I'm calling the function here, so hopefully it should run. So I'm going to come out of the existing execution and then again execute using node database.js. Okay, so over here you can see we are console logging the results. So you can see all the result. That means all our fruits are being console logged over here. So it has happened successfully. We have taken from the database and we are now bringing the data inside our own application, inside our own JavaScript file. So the next thing that we're going to do is, again, it's another subset of the find itself. If you want to find a particular fruit, so what do you do in that case? To find a particular fruit, again, we're using the, I'm going to use find fruit as the name of that function. It's going to be an async function again. I have a try block wherein I'm awaiting and the fruit.find is only happening, but I'm giving another parameter within that function, the find function, saying that find the document with the name kiwi. So once that has happened, and it will store the result, it will await for the result, store it in the results variable, and it will console log that as well. And you have the catch variable if there is any errors that appear. So I'm calling this fruit function as well. So let's see if this entire thing works as we desire it to work. I need to only have the kiwi document being sent in the console. Okay, so I'm running it and here you can see successfully we have only kiwi that's being filtered and here we have that document being displayed. Right, so this is another thing that we can do. And now the next thing that we're going to do is, if you want to perform more further operation within the documents that you have got, right? The document, if you see, it's all coming in the form of an array, right? It starts from here, array of objects. It's almost like array of JSON objects. So you can tap into each of those key value pairs and you can print them, right? So that's what we're going to try and do in the next part. Over here, I'm commenting out this code so that you can understand what's happening. Okay. So here, again, it's display fruit names. We're going to display all the fruit names only, not the entire document. So we are using an async function, try block. What's happening here is we're finding all the documents, where means this document will actually be in the form of arrays of documents, right? So that is stored. So result is definitely what? An array. So now if it's an array, we can easily loop through it. So we're using for each to loop through it. And for each of those documents, please console log the fruit.name. So you can see the name field. I want to console log that only, right? And I'm calling the display fruit names as well. So let's go and execute this. Okay, so let me, and there you go. You have only the fruit names that is appearing. So this is also successful from our side. Okay, so let me comment this out so that doesn't clash with what we're going to see next. So this was all about the find or the read in the CRUD CRUD operations. Okay, so moving on, we have update. So how can we update something in our database, right? So we already have things stored. So if you want to update a name, maybe you wrote maybe the rating has changed or things like that, then you have to update your document. So in that case, here I have a simple example, that is update by ID. So what we're going to do now, okay, here in this function update by ID, we can send in a parameter ID, and the try block, what it's going to do, it's going to use the function update one. Okay, when update one will usually take two parameters. So this is something you have to be careful. The first parameter is how we can figure out which document are we going to update. Okay, so the ID will make us figure out that this is the document we're going to update. What to update, we're going to write in the second parameter, right? So that is how simple it is, and then we can catch the error if suppose there is an error. And here we are calling it, and here I've given some sample ID, but for now we will give some specific ID. Maybe I want to change the apple field name to dragon fruit. Okay, so dragon I've written in short as dragon fruit in short, dragon I've written, but here is our ID. Okay, so I've updated the ID, and now let's run this and see if actually our apple is turning into dragon. Okay, so I'm updating it, and yeah, I think most likely it should have happened. So how do we check that? We have to print our console log everything, right, to check it. But you can check it like through your app itself, console logging this particular thing like display fruit names. You can console log this one, and then you can do it. Or otherwise you can just go to your Mongo shell, and I'm going to just find everything from here. And here you can see the first field, instead of apple you have dragon now, right? So I've updated it. So this way you can update anything. So this is a very fairly simple example of fruits and the fruit database and the fruits example. But obviously we can use this in many other real world applications. Maybe it's a login form, the person wants to update their email, things like that. Okay, so update is over. So our last part is the delete. So if you want to delete any document, what do we do? So here again, it's a try catch async function, and we are giving here, I'm giving a parameter name. So first thing, delete one. We just have to say one parameter, which just for it to find out which document you want to delete. So I want to delete the one, the name field, find it through the name field. And what is the name? I am passing it from here, right? So this one is actually, you say if I write f name, so write fruit name, so this is actually f name. Okay, this is actually the field, so that you can know the difference. This is the field, and this is the actual value that we're going to pass. So here you can see I'm passing the value when I'm calling the function as dragon. So the thing that we updated, right, we're going to change it or delete it now. So let me run this again. Okay, so then node database.js. So once I run this, let's go back to the Mongo shell, find all the collections. Here you can see just 3 documents are here. The dragon is completely omitted, it's completely been deleted. So this has happened successfully as well. Now in case you want to drop the entire database, if you want to drop the entire database, then you can use the db drop db or drop database function. So I'm going to show you how to do it from the Mongo shell directly. If you want to drop this fruits db, then you just have to write db dot drop database and click on enter, and here you can see it's dropped. Okay, although it appears here, but when you go and do show dbs, you won't be able to see the database at all. It won't be there, right? So in case you want to drop, so that's how you can drop it from your Mongo shell. And coming back to our presentation, so here I have all the Mongo shell commands in one slide. You can definitely take a screenshot of this for later use. And nextly, let's move on to the weekly task 6. It's going to consist of a quiz with 5 questions, and the deadline for that is August 12 before 12 p.m. And it's fairly easy. If you have watched this session from beginning to end, you can directly go now and do this quiz and get a very good result as well. So this is it for this session. In the next session, we will be tackling how we can combine all that we learned throughout these weeks and build on our to-do list app and connect it to the database, retrieve information from there. So it'll be like a whole complete full stack project that we'll be having. We'll be live coding next week, and that will be very helpful for you guys to do your capstone project that's due in week 8. So thanks a lot for watching, and see you all in the next session.